Welcome everyone to the GSA webinar series. I'm James Corsi, GSA's Executive Director, and we have a great and timely session for you today on the evolving role for architects and architecture in the creation of sustainable, efficient, and profitable spaceports around the world. But before we introduce the panelists, I have a few housekeeping matters to address. I want to thank our title sponsor, RS&H, and our co-sponsors, BRPH and Merrick & Company. Thank you all. As promised at the last webinar, I want to just touch on some of the subject matter that we will be covering in the summit on January 29. Jim Bridenstine will be our keynote speaker, and he will be followed by Pam Underwood from FAA and Colonel De Silva from U.S. Space Force. We'll also have the regular member updates as we have every year. Now, during the course of this year, GSA has established a relationship with the Hague Institute for Global Justice, and we've formed a partnership to enable near-term testing and operations of vehicles capable of performing point-to-point. We will hear from them, and this will tee up a panel discussion with George Nield, Oscar Garcia, and the Institute on point-to-point. This session will be also followed by a session with the International Space University, with whom GSA has partnered. And we will hear from its US leader, Ken Navidian, who will give us an overview of their goals and ways they can add value to GSA. Finally, in cooperation with Spaceport America, GSA will conduct 4 webinars next year on the development of workforce development. And anyone interested in sponsoring or participating in these sessions, please contact Steve Wolf or myself. Now, this agenda can be fluid, so if anyone has a topic they would like us to consider, please reach out and let me know. Just as a constant reminder, please register for the summit as soon as you can. And also remember to register for Space Mobility and Spacecom and take advantage of your member discounts. And now, just to say a few words, introduce our panelists for today's webinar. Here is George Nield, GSA Chairman. Over to you, George.
And greetings, everyone. Just a couple of reminders about some upcoming events in which GSA will be partnering with some other organizations. On Thursday and Friday of this week, Oscar Garcia, who is the chairman of our point-to-point working group, and I will be co-chairing a gathering known as the High-Speed Aerospace Transportation Workshop in Midland, Texas. If you're not able to attend in person, I know that Oscar will be able to have a great summary of that at our Spaceport Summit coming up in January. Also, there's going to be a special event known as the Human Research Program for Civilians in Spaceflight and Space Habitation, which will be held at the Oklahoma State University on January 23rd and 24th. We've got some great folks coming in to talk about how we can understand the impact of spaceflight on regular people as opposed to NASA astronauts who typically are a lot younger and healthier and in much better physical condition than the rest of us. And we're trying to really bring all the experts together to see what kind of a going forward research program we can have that will enable more and more people to safely go into space. So there'll be more information about that coming out in the next couple of weeks, but I hope you'll be able to join us either in person or virtually. So turning to our program today, I've got a great topic to discuss: designing spaceports for form and function. As you know, there's a lot going on in commercial space these days, especially with regard to spaceports. Just in the Global Spaceport Alliance, we have 27 current or proposed spaceports from 9 different countries all over the world, and there are other ones who have not yet joined GSA, but there's work going on. And as this group knows very well, all spaceports are not alike. We've got vertical launch, horizontal launch, spaceports that have evolved from or are co-located with operating airports, spaceports that involve upgrades, modernization, or otherwise using existing launch locations from government or military launch sites. And we've got spaceports that are starting from scratch and just plan to build everything up from the plans and the visions of its founders. So today we've got a great panel, including Alice Schultz, David Acomb, Francis Walker, and Jen Spears, that'll be talking about their perspectives on where we are today in the industry and where we're likely to go in the future, with different perspectives on how spaceport facilities and infrastructure can not only provide a safe location to operate from, but also be a focal point and technology hub, if you will, for the global space economy in general. So let's start off with Alice Schultz. Alice is an experienced senior architect with a demonstrated history of working in the commercial, industrial, and aerospace design industry. She's skilled in addressing ease of access and functional space design, along with infrastructure security and building envelope performance. She has strong attentive listening and client interface skills in establishing programming and schematic design, problem solving, material research, and writing effective technical specifications. She is a design professional with a certificate of sustainable design focused in sustainability studies from Boston Architectural College. Alice, over to you.
Thank you. I am Alice Schultz and getting ready to share my screen here. I'm with RS&H, and I would like to share 3 things important to spaceport architecture: the traditional role of architects and architecture, the launch-induced environment, and the special future challenges of spaceports and spaceport architecture. The traditional role of architecture is aspirational, functional, and increasingly sustainable. I designed the Propellants North Administration and Maintenance Facility, the first LEED Platinum building at Kennedy Space Center. And you might ask, what role can an architect play in the design of launch support facilities and assist in spaceport development? And my answer is that architects are systems thinkers, trained as generalists to consider everything and everything in relationship to each other. Architects see the big picture and the details, and we're familiar with addressing the multiple, sometimes competing priorities. Architects can be a very helpful, welcome voice around the table as our terrestrial nations look outward. We see everything in relationship to one another, which allows us to be effective integrators, adept at facilitating and fostering the collaboration necessary for that integrated solution. Seeing the big picture as well as the fine details, this is a building that achieved net zero efficiency due to the proper siting, appropriate building geometry, and a robust envelope that was equipped with the solar arrays. Salvaged materials incorporated in this facility include the original aluminum bow trusses of Kennedy Space Center's Launch Control Center. In traditional architecture, buildings wrap like clothing around the spaces to provide environmental needs of the occupants and celebrate the activities, which are often open to the public, that happen within and around them. And people are usually the main event. Buildings are designed to be engaging, inspiring, and efficient, but buildings not only clothe the activities within, they frame, influence, and respond to their surrounding context. RS&H designed the replacement of the original 3-ply tinted laminated glass at the Kennedy Space Center Launch Control Center with insulated units suitable for this high velocity hurricane wind zone. And this allowed the removal of the former shutters, opening up the views to the launch. The shutter removal and window installation was accomplished while maintaining the operations to keep the shuttle launch cadence unaffected. Architects helped to facilitate that process, and we have a legacy of federal aerospace launch support infrastructure available to inform commercial aerospace and commercial spaceports across the globe. Architects design for public health, safety, and welfare, and are skilled at delivering high-performant, resilient building designs. They're experienced in integrating building systems, addressing code, functional, and user requirements. But I'd like to talk also of the importance of the launch-induced environment. Building codes have been developed to set minimum standards for traditional architecture, and launch support facilities may not fit into typical building occupancy and user categories. The design of these unique structures often require life safety and fire protection design analyses to assist permitting authorities who have the jurisdiction to understand them and approve of them. Architects can help spaceport owners and authorities see the whole and the parts and ensure that a practical, functional, and aesthetically pleasing integrated design solution is constructed. Function is foundational, and architecture is designed to address the local climate, engineered to withstand wind loads, snow loads, and their thermal comfort to UV and salt fog exposure. We do designs to minimize maintenance and reduce the effects of weathering on buildings. For design within the launch-induced environment, which refers to the exposure to blast, extreme temperatures, aerospace facilities need to be designed not only to prevent and protect against corrosion, but also to withstand and handle thermal deformation, address acoustic impacts, and deal with the vibration and blast. So designing for aerospace processing and vehicle assembly involves not only the design within that natural climatological environment, but addressing the unique conditions of the launch-induced environment, addressing the safety of people and payloads, and designing for survivability. Designing for operational efficiency and flexibility means designing for adaptability, often incorporating kinetic or moving architecture. Aerospace architecture must be designed to support the launch vehicle to provide the environmental control systems, gases, commodities, communications, in other words, the subsystems, in addition to the facility systems needed literally to support the vehicle, the processing, and the payload handling. And people still play important roles. However, the occupant load is much lower in these factory industrial uses, and the specialized workforce is trained to work in areas that may have confined spaces, contain hazards. So some of the examples of launch support infrastructure can include the mobile launcher and the vehicle assembly building, the renovation of which provided 10 pairs of adjusting, biparting, sliding platforms with interchangeable cores to accept a diverse family of new launch vehicles. The mobile launcher is like a big building, yet it is transported and parked in different locations for vehicle processing and launch. There's no east, south, west, or north orientation. The main event is the launch vehicle, yet people, if you see those folks in orange shirts on the upper level there, are still part of the process and still need protection. The swing arms that you see there retract with lots of force. And designs for launch-induced environment need to address the safety of people and payloads, address survivability, be designed for efficiency, flexibility, and multiple users. And they may need to accommodate some unintended users, like this raccoon who decided to curl up under the stair. The special future challenges in spaceports are not only the multiple user requirements and functions. Spaceports are going to be centers of commerce, economic engines across multiple different users, not just about the rocket anymore. It's going to be aerospace, but it's also going to be tourism. It's going to involve science and technology, engineering, and the environment is going to be dangerous. We're going to have quantity distance zones for launch pads, and these areas are going to be destinations, events that need to safely operate within an environment that has to also accommodate those explosive setbacks. This facility, this concept design is oriented not only to view the main events of the launch pads and the activity of the landing strip, but to facilitate the scientific research, the processing, payload handling. Architects have lives in their hands in the design of spaceports, and we've got the concern not only for the contamination of what we may bring back with us, as here at the Johnson Space Center Asteroid Curation Laboratory, but we also don't want to bring contaminants into space with us. We've got challenging operational environments, and architects can benefit spaceport planning by asking the right questions to understand the ConOps and create a master plan for development of that infrastructure. Architects can benefit the design of spaceports by bringing their design skill set in evaluating that climatological data, siting facilities with regard for blast danger areas, orienting them to the protection from natural and induced environmental impacts. We understand how integrating the vehicle support and processing can occur with consideration for human interfaces for inspection and checkout and ensuring safety for all. Thank you for this opportunity to participate in the discussion today. Spaceports require many systems and the teamwork of a lot of experience. They need lightning protection systems, water towers for deluge systems, a host of other requirements. And as we envision the cislunar and outer orbits, including architects in planning, design, and construction can serve not only to satisfy the needs we know about, but anticipate those that we've yet to discover.
Excellent. Thank you very much, Alice. We'll move right to Francis Walker. Francis leads Corgan's London Design Studio with designs in spaceports, airports, and vertiports. This new integrated infrastructure can influence and drive the creation and development of cutting-edge communities focused on connectivity, technology, and well-being. These ideas have been expressed in visionary design concepts for Riyadh King Salman International Airport, Neom, which is a new urban area planned by the Kingdom of Saudi Arabia, Uber Elevate, and Spaceport Ecuador. A strong advocate for design, he believes sustainability must be embedded in the design process, an architecture which serves to challenge and inspire. Francis, over to you.
Thanks, George. Thanks for having me tonight. Let me share my screen. Can you confirm you can see my screen that I'm sharing?
Go right ahead.
Okay, great, thank you. So I'm Francis Walker with Corgan's London studio, and we have a long history in airport design, and as a natural extension to that, we're looking also at vertiports and spaceports. So if you take all three, we kind of call it integrated infrastructure. And by extension, we're looking more and more at how these established and new modalities can influence communities and the kinds of places that we want to live. Today's presentation is, I've taken the position that we're very comfortable with visions of the distant future, 500 years in the future, we're going to fly between planets and it's all good. And we're very comfortable with the here and now and what we have to do and what's right in front of us. So what I'm going to talk about today is the near future or the middle distance, the 20-year window, which I believe is very significant to how space takes root and provides opportunity to this coming generation. And that's a big part of the focal point of this presentation today. What I want to talk about first is cities and how we take for granted how cities work, that they are based on trade. And if we look at these two images, they convey very different things, but actually it's the same thing. It's how do we move goods across the world? Where do the trading ports develop and how do cities grow around them? So what this actually describes is an acceleration of the same technology over time. And it's kind of the same with with this image here. You know, a lot of our cities were designed for the horse and cart, and by extension, the vehicle. So transport and trade are the things that have driven city development at the biggest scale. Of course, you have layers of lifestyle and culture and different things, but those are the kind of two big drivers that define, if you like, urban design, urban form, and the way cities are laid out. So, for example, London, the city I live in currently, has great landmarks, has great cultural institutions, has great entertainment offerings, but it's also very congested. It's grown and absorbed neighbouring towns and villages, and over time, it's become kind of a patchwork of things. And I think the observation here is that the these cities, they shape our behaviour because of the way they've grown, and the way we live in them is defined by the physicality of the city and the fact that people want to live in big urban centres, and that's the 20th century model. So what we're going to talk about today is, does space represent a different way to think about this, and are we at a point with space where there's kind of a convergence of lifestyle, of technology, of career opportunities, of talent, of global communication, where we can start to think about the community and the city aspect of this in a slightly different way. And what we're talking about is maybe a city concept or a community concept, which is not it's not zoned physically so that things are kept separate. It's integrated. It's integrated vertically through the research, the innovation, and the design to manufacture and product launch. And it's also horizontally across all aspects of the sectors that we think or we know we are going to need in order to viably go to space at scale and de-risking any aspect which is a threat to human life. So just to touch briefly on, that the new opportunities where we are more connected through digital communication, where we have new modalities that are emerging that make the distance between places get smaller. We have Hyperloop, we have eVTOL, we have things coming online which don't require us to make these physical surface connections between things that tend to break up the spaces between and around cities. So there's interesting opportunities here that are a bit different from what we had before to work with when we grew our cities. And then we've got things like vertical farming. How do we feed large communities in space? How do we get the renewable energy that makes it viable for us to go up and be in space? The space medicine, robotics, the technology that we're going to need to have permanent bases up there. And then also the sort of feedback loop between the technological and medical advancements that we can do there and the benefit that they would have to us on Earth. And of course, entertainment and education. These are sort of increasingly overlapping in the way people learn about things. Certainly, the interface for education is starting to look a lot more like entertainment these days, and I think that can be a good thing. So what we get from that is the possibility of a new urban model, which sits beside the existing, car and trade-driven cities that we have. This is not a replacement, but maybe this is something for us to think about as we think about spaceports and as we safeguard for the future on spaceports. This is a lesson learned from aviation, where the master plan should look 20 years ahead, and it's not always about spending money today, but it's about safeguarding for something you might need down the road, and making sure that when you get to that point where you need it, you haven't put something else in that place that prohibits that from happening, makes it more expensive, makes it more difficult. So it's just about looking ahead, thinking about these smarter cities that are more aligned with lifestyle preferences, with the greater integration of technology into culture. And ultimately what we're talking about is a decentralized, interconnected urban model. It's not suburban, it doesn't sprawl, it's concise, but it forms network clusters that are integrated with nature. And this is an interesting thing that I think is very appealing about this idea, is that you can have almost a binary relationship between built communities and natural landscape. This feels like something where you're in a sort of intensified community space, but it's very easy to get out. In some ways, that reminds me of Hong Kong, where you can be in a very urban environment, very urban experience, but in 10 minutes, you can be in the jungle. So I think that's kind of where that influence comes from for me. So to take a look at the spaceport template, yes, we have the launch sites, we have the vertical, we have the horizontal, we have good connectivity at sea and air. But what I've highlighted is are there spaces that we should be providing for or allowing for that are these communities of the future? And so what we did was we wanted to build some prototypes to convey the idea. And this is really about something where we would do community engagement to show what these places could be like, how they could be very livable places, to get young people moving through education with a thought on space, thinking about, I would like to live there, and I would like to work there, and I would like to get out of there very easily. So that was kind of the idea of, as the space sector and the space communities evolve and take root, there's going to be competition. And what's that competition? How will the best talent make choices? They'll make choices like they do today with cities. I want to live in New York. I want to live in London. I want to live here. I want to live there. Spaceports, I think, are going to have the same competition for talent. So we had some fun placing our sort of spaceport typology in different physical locations around our planet, both as a way of contextualizing them, as making them not generic things where you could be anywhere, but as making them, giving them a sense of place, giving them a sense of context. So here we see it in kind of a green kind of Mediterranean or Northern European type of climate. And what we're looking at here is connectivity to air modality. We're looking at a place which is centralized, which has good eVTOL connectivity, and which has a cross-pollinated program. So, you know, these are not worked out spaces, but the text gives you a sense of kind of the cross-pollination of different types of functions that are put together in one place. The big idea here is that the gamers and the medical researchers get together and come up with something new that you cross-pollinate with by taking specialists in each area and you put them together, and that's when I think you get the unexpected happening. And it's a place that you would want to live. It's a community that that has great community aspects. It has great integration with nature. It looks like a place that you might want to live and work. And I'll go through. We had a lot of fun making these, so there's quite a few of them. But also, what we want to do is we want to build up a language, a kind of iconic language that identifies spaceports as a place that you would want to spend a good part of your life. 2/3 of the Earth's surface is water, so we could put them there. That has obvious advantages for some types of launch, but also maybe it becomes more geared towards tourism, and it can be part of an aquatic network of spaceports that are connected in fun parts of the world. Same diagram again, just looking at the cross-pollination of function. And we've got the launch from sea. We've got the spaceport community. So this is really about building up an image of what this could be. It probably would be something different, but it's a good starting point for a conversation. And again, it's concise. So when it's filled, it networks with one that you build adjacent, and then the advantages of each compound. So you can have specializations in different places, but they come together to form a network. Some can have launch, some can be clusters that support larger ones that have launch. And again, from the aviation sector, that's an equivalent to the hub and spoke idea of large hub airports serving smaller regional airports. So the idea here is that we plan for this, that we think about it, that we think about what we're going to need, and also importantly that we treat the big ideas and the big visions and the big statements that sound sort of half science fiction, that we treat them as milestones. We treat them as, this is going to happen. We need to not get too excited about it because it's going to happen and we need to move towards that. And here's what we need to do today for something that the next generation might pick up. But what you want them to say is, it's good that they did that, isn't it? Because now we've got a much clearer path to what we're trying to do, rather than, why did they do that? Because now we can't do X, Y, and Z. So I think this is a big part of it, is understanding that we can move this forward, and then pass the baton to the next generation to really make changes that we can't imagine right now. and we can put it in our most hostile environments so that we can use it for testing things that will give us a simulation or a sense of how things might perform when we take them onto other planets. And so just finish with some views of the, you know, what is a vision for us of a spaceport community. So thank you. I hope that wasn't, I hope I'm on time.
That's great. Thank you, Francis. Appreciate that. Why don't we go ahead then with Jen Spears. And Jennifer Spears is Vice President of Engineering for American Company. She received both her bachelor's degree and master's degree in structural engineering from the University of Illinois at Urbana-Champaign. She's a licensed professional engineer, structural engineer in 13 states. She has 14 years of service with Merrick and 22 years of structural engineering experience. Jen was a structural engineer of record for the superstructure for the Space Launch System Liquid Hydrogen Cryostructural Test Stand at NASA's Marshall Space Flight Center in Huntsville, Alabama. In her spare time, Jen enjoys speaking to students at her children's schools about the history and future of space exploration and hoping to spark the interest of future engineers and/or space explorers. So, Jen, over to you.
Thanks, George. Okay, so to get started, I'd like to give a quick little background on Merrick and Company. So Merrick was founded nearly 70 years ago by Sears Merrick, a former engineering professor at the U.S. Military Academy at West Point. Merrick's initial focus was on structural engineering, but grew into power engineering and surveying. Since then, Merrick has grown substantially and now has well over 900 employees spread across 25 office locations in 4 countries. Probably not entirely unique, but Merrick has executed projects on all 7 continents, yes, even Antarctica and McMurdo Station. As you can see, Merrick serves a very diverse group of markets, in part to build our company's resiliency, and our clients span a wide spectrum to include the United States government, National Aeronautics and Space Administration, Department of Energy, state and local municipalities, educational institutions over the left, and manufacturing companies. Within this realm, Merrick provides general engineering and architectural design services, landscape architecture, planning, geospatial and surveying services, consulting, system commissioning, and design build services as lead designer. Merrick has been supporting the space industry for well over 20 years now. And the majority of our work has been with NASA, but we've done work with private space companies as well, supporting them at various stages of the space launch cycle. To oversimplify it, the space launch cycle, as we call it, typically includes testing, manufacturing, assembly, launch, and return. Some sample projects representing the testing stage include the Space Launch System Liquid Hydrogen Tank Test Stand, the Space Launch System Liquid Oxygen Tank Test Stand, both of which are at Marshall Space Flight Center in Huntsville, Alabama. These test stands were designed and constructed to enable NASA to cryostructurally test the new hydrogen and oxygen fuel tanks for the new SLS rocket before progressing to manufacturing, assembly, and launch. Both stands were designed to accommodate the test parameters of the current tank test articles, but also to provide a means for testing future unknown test articles. The SLS LH2 test stand is 212 feet tall and consists of 2 towers on either side to enable, with platforms at approximately 10 feet to enable access to the test article at multiple elevations. Raising and lowering of the movable load deck, or crosshead as we called it, supporting the test article is accomplished with the movable crosshead at the top that can be moved with strand jacks or cranes. The LOX test stand was 85 feet tall and had open sides on 2 sides to enable different configurations as well for testing, allowing for different future testing configuration for loads to be applied at virtually any elevation. Creo was used for complex stress analysis and connection design for both test stands. We've also done work at processing facilities and operations buildings. The MSAT expansion is a 50,000 square foot space equipment testing, clean room, and manufacturing facility located in Baltimore, Maryland, containing clean rooms, high bays, and thermal conditioning areas. We also did work at NASA's Kennedy Space Center Operations Support Building for the OSB-2 roof replacement due to hurricane damage. We've also done work at Johnson Space Center Emergency Operations Center for the requirements document that included coming up with a plan for keeping the building operational during hurricanes and extreme flooding events. Some of our work has also been in the vehicle assembly building at Kennedy Space Center. This is an iconic building, obviously. We've done work designing 2 new extensible platforms for the SLS program and modifying 4 of the existing platforms. We've also done several various studies within the building to look at ways, potential modifications that might be used to help accelerate launch schedules. We've also analyzed the entire building and looked at what needed to be done for remediation for supporting new loads. So all that to be said, how do we see the spaceport map? The space launch cycle, as we consider it, consists of testing, manufacturing, assembly, launch, and return. Typically, those currently aren't all at the same location. They're often not even the same state or even country potentially. And that incurs additional costs and transportation considerations. You have to get those components from one location to the other. That takes additional time, additional coordination. From our experience, a better option when considering spaceport design is consolidation, putting more of those processes together at the same site. That definitely saves on the transportation aspect. We've got a project under construction right now that one of the things that they're considering is how to get one component from one place to another. The current plan is that they're going to have to actually cut down some trees and move some traffic lights in order to get that component down the road. That's something that takes into consideration. That definitely takes additional time, consideration, money to do that. If you compile them all together, then that's definitely a savings. Also the efficiency effort. If you're paying for a lot of the spaceports, just need more water, more power, more of everything as these space vehicles get bigger and more powerful. Having to increase or add infrastructure at multiple sites is going to be a lot more expensive than having to add it or increase it at one site or less sites than one for every individual step of the space launch cycle. Some other considerations are environmental approvals. As we've seen with some of the things that happened down in Boca Chica, Texas, getting those environmental approvals and knowing the impacts of the operations beforehand could be advantageous as opposed to trying to handle them after the fact and make modifications as you're already trying to work on things. The public approval and enthusiasm is another consideration that we feel is important in the spaceport design consideration. Kennedy Space Center is an example. When it was first created in the 1960s, there wasn't much around it. So there wasn't much concern about it affecting the people right around it. The people that have moved to the area since there, they knew coming in that there's going to be, the noise and the vibrations that comes with living near a spaceport. So that's something that, if you take a new spaceport and you're going to plop it in the middle of a city, that might be met with a lot more hesitation and potential negative press, et cetera, about that when those people aren't used to having the considerations that come with living near a spaceport. Considering that is something. From our standpoint, having something that's iconic, having a visitor center there. Again, Kennedy is another example. They've got the visitor center that's right there that allows the public to come in. It really helps foster that enthusiasm for space exploration. The vehicle assembly building is a very iconic structure known around the world that helps everybody identify with Kennedy Space Center as just one particular example. All of those things, I think, help increase the public perception and approval and get that public enthusiasm about it, which just helps the space industry grow and the spaceport itself continue to be more successful. Another aspect of spaceport considerations are the accessibility. If you've got a spaceport that is only accessible to a few big space entities, then your designs can only go so far. Space travel, the space industry can only go so far. If you've got something that's accessible to some of those startup companies that really lets them get the foot in the door, then that lets more people come into the equation, and with more people, I think, comes more innovation, more ideas, and more growth. And more growth is always a good thing for the space industry. Collaboration is another thing that comes in with that as you've got more users at one potential spaceport, then you've got more potential for collaboration. That comes into that innovation and sharing of the ideas, and that will always help get the space industry that extra boost and growth that we all are looking forward to. And with that, and I will turn it back over to George.
All right, thank you, Jen. Okay, let's see how David's doing on his computer. You Next up, we have David Acomb. David is an architect with over 40 years of experience who began his career at WED Enterprises, now Walt Disney Imagineering, during the construction of Epcot. His work spans diverse project types, including museums, institutional buildings, commercial projects, and innovative design that have impacted fire stations across the nation. More recently, David has provided architectural team leadership on 3 multi-million-dollar projects associated with the space industry and commercial spaceflight. Each project is unique in its geographic location, client vision, technological overlay, and brand identity. As a leader in the industry, he now focuses on sustainable and responsible design for project development and clients. David, over to you.
So first off, AOA, we've mostly been working in the commercial side of the space business. So not a lot of governmental elements there. You know, obviously our clients are profit-based with what they're doing. However, the absolute enjoyable thing for us was our clients had a very similar mission. We were working with 3 specific clients in the last 2 years. Besides the money profit side of it all, what they were all coming back to us was, we have a mission of sending people into space, and that mission is to have people experience that overview effect and come back with a true understanding of how precious Earth is and all the issues that are affecting it from climate change. The second thing they wanted people to understand is how space and technology plays a role in our everyday lives. And then also, what things can they do? Let's face it, most people that go up have a means to be able to take those flights, and can they be transformed when they come back to become ambassadors of a lot of sustainable elements, a lot of technology that, again, will help save the way we do things on Earth. One thing that we had found is in researching spaceports and the issues they deal with, on the spaceport side, the economic benefits are always the primary thing: creating jobs, increasing space tourism, changing communities. The negative side of that is you're putting carbon into the air, you're putting pollutants into the environment. There's issues with noise, there's issues with even forest fires. And Camden, Georgia is a good case of that, where Not in My Backyard came to fruition. So what we want to do as we're going through our projects is make these green communities that people will understand that this is a antidote, if you will, to the bad elements that might come along with the spaceport. So it's kind of walking the walk. So as people are looking at this spaceport being built, or the space community being built, they're also seeing, well, everything they're doing there is counteracting the bad things, that they're being responsible with the design that they're creating. One thing that has been a common variable too is, as we start every project, it's looking at each one of those from the sustainable point of view. So it's looking at all the variables that may come into play, whether it's the site, the buildings, what kind of products we're using, what elements we really want to put on display, what experiences are available to really showcase that this is a different type of facility, and then also what's the educational opportunities that kind of go with that. As we broke it down, then we look at everything on the outside. You know, what are the solar orientations, the wind directions, what kind of climate issues are we dealing with, what kind of materials are in the area, what are the issues with water. Then we look at the indoor environments, what kind of building spaces are we going to create from an energy and material point of view, how susceptible are they to clean air, you know, what kind of new opportunities are available, how do we deal with waste, how do we deal with the building water supplies, and then what are the experiences that we can add to that to start to become educational opportunities for not only the staff that's there. I mean, the staff can become the biggest ambassadors to your spaceport or your space complex as far as getting that education out there into the community. So we really build on that as we're into that design process. You know, architecture is an immersive experience just by nature. You know, what you see in the form language, what you see in materials that are used, start to create that element of understanding that this is different, this is renewable. This is energy conservation. This is doing all the right things. So we start to look at what can we bring into the site, whether it's artistic, whether it's just the practical language that everybody relates to, but anything to make this feel different and also feel like it's part of a green community. We've looked at all kinds of new systems for how do we take wastewater and purify it into potable water on particular sites. This is all new technology, but we look at these new spaceports as being these laboratories, if you will, for sharing all this new technology and putting it out there for people to understand that there are things that are changing. Now, it was mentioned before, but water efficiency and high-tech greenhouses, incorporating those into these complexes has become a very forward-looking opportunity to be able to show that we can use hydroponics. We can grow food in very arid climates that we're working in. Our projects that are in the Southwest with those dry, arid climates is like we want to bring agriculture back to those areas and show that this is a opportunity for that community to have something different that's there. And also, again, it's the education of all the workers and the guests that are going to be on board. We go through a process of looking at all the different materials, whether it's rammed earth is something we've looked at, clay tiles. What we want is highly efficient facades to the buildings to make them the most energy efficient as possible. So we kind of go through this deliberate process of not only the form of the buildings and what they look like, but what are the materials that we're going to put on it so they convey that message of this is recycled, this is sustainable, this is responsible. For the interior of the buildings, active green walls, air purification, all of that stuff. Again, it's a visual image. It's that immersive entity to a building that's important. Again, it's how people work and live on these sites. And at the end of the day, as we're moving through this quickly, is we kind of come up with this master plan of all these opportunities on the site to make this building and this site sustainable. And then we start to go through that process of how do we make it work? How does it fit within the big picture? What is new technology? How it works with the budgets? So it's, again, a very extensive process. It's kind of hard to show here in a few minutes, but it's playing a big role in what we're after as a final product. And then what I will do here is then go into showing some examples as we've worked our way through. Again, the form language in this particular case, starting to build some of these buildings into the ground, providing shade, providing photovoltaics on the roof elements, heavy overhangs, bringing natural light into the buildings as much as possible. I mean, one thing that we all have in common here with this presentation today as architects is we've been promoting sustainable design for decades now. And for a while, it was like pushing an elephant up a hill. Now it's become more mainstream for a lot of the obvious reasons. And that creates that opportunity for us to showcase a lot of different ways to design, a lot of different ways to build, a lot of different ways to use materials. So again, it's creating an outdoor environment in this one particular project where we're trying to incorporate forms, use indigenous materials, and create a real sense of place on a particular property. Again, the deep overhangs, different ways to bring natural light into the buildings, again, to provide passive technology for the projects, cooling towers in some of our arid climates. A project in Florida, it's showcasing timber. Again, it's that immersive experience of the visual connection of this spaceport, this space facility is trying to do these things to make it responsible design and responsible to the community. So again, just some examples of kind of some of the projects we're working through. And then again, solar on the passive side, the active passive elements that kind of go with these projects. It's the recognizable stuff. The solar panels show you that you're doing an active system that's on the property. Ways to affect the grid, ways to, and that's one way to work with the community. If we can bring the water sources, the infrastructure, the solar into a community whereby they could benefit from that. Okay, and with that, George, I'm right at 10 minutes, so.
Very good, thank you so much. Okay, so we have a few minutes left for some questions. There was one question that I saw came in that was asking, is there any regulation about how many spaceports can be built and who can build spaceports and what are their minimum requirements for spaceport building? So just quickly, let me take that one. In the United States, again, there are laws and regulations that govern the licensing of spaceports, and the FAA has responsibility for that, but their primary focus is public safety. And so if an applicant comes along and wants to put a spaceport in a particular location, and they can show how it meets all of the safety, environmental, and other requirements in the regulations, then they will receive a license. And it's up to them to, of course, go out and get some business to have people who want to live, operate, and work there. Part of that process involves environmental reviews, which can often be the long pole in the tent. So let's just have a quick lightning round of some other questions and very short answers, impressions from folks. Some of our folks in the GSA or listening in today have spaceports in operation. Others just have a dream to build one someday. What would your advice be in terms of when is the right time to engage with an architectural or engineering firm to start looking at some of the things that you all were showing? So Alice, any thoughts that you had?
I would say as early as possible.
Okay.
There are ideas that are going to come out of those early conversations, and to help set expectations and timelines, I would say as soon as you start thinking about it, ask your architect and design team to be at the table to hear what you're thinking.
Okay. David, your thoughts?
Yeah, even before you buy the land, there's a due diligence effort that you have to go through. You don't know what landmines that are out there. And then also you have to have a good understanding of just how much square footage and size of the project that you're going to have. And then it's all the infrastructure that comes into it. So before you would make, a huge monetary purchase of a piece of property, it's best to involve the team and get all that stuff out on the table as early as possible.
Okay. Francis, your thoughts?
Yesterday is probably about the right time. Just to build on what David and Alice said, I think that the community engagement is a huge part of it. And I think what we can do is we can create an image of what this can be. And I think that's always good because it makes the project relatable to people. I think we can talk about a lot of the technical stuff and the need for it and what happens in low orbit and stuff like that. But I think, what does it mean to people? What does it mean to their families? What does it mean to their children? And I think we have a big focus on that. We're used to talking on those terms on different projects.
Very good. Okay. Jen, any thoughts?
The same that everybody else said, today, yesterday. I think the sooner the better, so that we can help you guys get ahead of what needs to be there, and so that we can help you plan and really have a better understanding of what's all involved.
Great. Okay. Different topic. You've shown some beautiful designs and some magnificent accomplishments already. As we think about what needs to be done either to upgrade or modernize or to start something from scratch, one of the big issues obviously is money, the funding for that. And we're not necessarily following the traditional approach of, okay, the government provides this amount of money to do this particular task. I'd be interested in your perspectives on ideas or things to consider or things to research or to check out in terms of how to arrange funding for some of the kinds of facilities and other infrastructure elements that you have been discussing. So Jen, why don't we start with you and go back?
Sure. I think that's another thing. We're bringing architects and engineers, your design team, on ahead of time. At the very beginning can help. We can come up with those preliminary, design drawings, preliminary views that can help get that additional interest from both private entities and from state and local municipalities, get them on board, really let them know what we're planning, what's going to be in the backyard, and help get that approval ahead of time.
Okay, Francis?
Well, two things strike me. Coming from aviation, where large aviation projects are with a lot of private investment, they're coming from investors that have long-term return on investment goals. They're not looking for a quick buck. So those tend to be ones that are looking at 25 to 30-year concessions. I think Spaceports is a 50-year 50-year to 100-year concession. So related to that, I think you have to diversify your revenue streams. You have to look at everything that a spaceport could be and look at short, medium, and long-term goals and see how you can make money. Airports make, in the US, airports make half of their money from car parking. In some parts of the world, they make half of their money from the retail. So it is really about finding the different ways that you can make money. I don't think we're naive that just because space is cool, people should spend money on it, as much as I would like that to be true.
Okay, good thoughts. David?
Yeah, it's certainly complicated, right? There's so many variables that are there. The municipalities, if there's an economic advantage to the spaceport being there, obviously there's a piece of the pie that can be a contribution that comes from that. There's if you start to break apart the elements of it, for example, the whole solar renewable aspect to it could be privately sourced as part of a project, as through the utility companies, for example. The infrastructure to the spaceport, all that could be, again, a separate element that's financed outside of the actual project itself through the municipalities. So if it's a county road, for example, or a state highway or that's going into it. So it's that due diligence again up front, start to look at it. And it not only is one large project, but what are the individual pieces that you might be able to break out and see where there's possible funding coming from, because there's so many sources out there to kind of tap into right now.
Okay. Any thoughts, Alice?
I agree with the comments that others have said about, I think David said, thinking about spaceports as laboratories for sharing new technologies, a phased implementation plan, starting first with that vision, casting that and getting the community buy-in and approval. That acceptance early on is important, and then being able to define how that growth happens around the diverse centers of potential revenue through those public and private partnerships.
Okay, sounds good. Okay, let's finish up with one that's looking to the future. So based on what you're seeing today in commercial space, any predictions, observations, hopes or expectations on what the spaceport community might look like, say, 10 years from now or even farther into the future? Jen, any thoughts?
I think that, as I discussed, getting more of those entities at one location, getting more of the phases of the space launch cycle, as we call it, at one location will continue to help in making sure that we have a space that those startups can get into. I think that will help us grow.
Alice, your thoughts?
I think we can look and learn a lot from the aviation industry in the growth and traffic patterns and set some new expectations for those spaceports to be similar hubs.
David?
Two things. One, I think they're going to be huge incubators for all kinds of new industry that supports the space industry. And then also, I'd say the physical side of it all these things are sort of trying to head down a path of net zero, self-sustaining communities and facilities. So I think that's absolutely going to happen, but there's going to be plenty of opportunity for a whole workforce around these spaceports to support what needs to be supported.
Okay, Francis, we'll give you the last word here.
It seems to me that cities, when you look at how cities evolve and develop, they have landmarks and monuments, and they have pieces that create the uniqueness of the city. So I think spaceports which develop their own mythology, whether that's digital or real, to create something which has a stamp of individuality on it, is where I would see the big success coming. And ultimately, what I would like it to happen is that all the wildest ideas that we have now are considered quaint in 20 years.
Amen.
Excellent. Wow, what a very interesting discussion. Thanks so much for participating today, Alice, David, Francis, Jennifer. Great discussion today. And we'll turn it back over to James to wrap things up.
Wow. Well, again, thank you, George, and thank you, Alice, Jen, Francis, and Dave. What a great, great presentation. We're sort of right at our time, so looking forward to seeing you all at January 29 in Orlando. Please, if you have any suggestions for topics, feel free to reach out to me directly. So thank you all very much for today.